Hi, my name is Ramika, and I'm going to be talking to you guys today about fun with APIs and Ruby. Talk is also known as Git commit messages are forever. So a little bit about myself. As I said before, my name is Ramika Gayhart. You can find me on Twitter at CC and UC, and I'm currently employed at a consultancy here in Boulder, web development consultancy called QuickLeft. I'm also a graduate of G School prior to the Turing G School split, so I get to say I'm a double alum. Today I'm going to be showing you how to make Mad Libs with Ruby and the GitHub API. So let's go over the plan for the talk. We're going to cover what is GitHub, what's an API, fetching data, making the program, showing the data, and of course the most important step at the end of any programming venture is how could we have done it better? A little bit of a retrospective. So what is GitHub? I'm sure you guys have all seen the Octocats everywhere, but do you actually know what GitHub is? GitHub is a Git repository web-based hosting service which offers all distributed version control and source code management functionality of Git as well as its own features, which in English is GitHub is basically where you put your code. It allows us to share code using Git, and it helps make open source work possible. So I'm going to show you a GitHub profile, mine. This is me. These are the projects or the repos that I've worked on. This is my public contribution history. This is the period of time right after I graduated from G School where I was extremely lazy. This is where my work goes, both my personal or open source work and also my day job at QuickLeft, which you don't get to see much of in here since most of it's done in private repos. So what's a commit message? Every time you put your code into Git, you add a message. Things like fixes logo image and centers, minor changes to font colors, redirected menu page, and removed cat photos. Commit messages are super important. They live in source control pretty much forever, and believe me, your future employers will judge you for them. So what's an API? Well, what I just showed you is a GUI, or a graphical user interface. It's basically what lets this guy get onto GitHub and use GitHub easily. An API, or an application programming interface, is basically the computer's GUI. It's what lets the program use the data easily and programmatically. That's what we're going to need for our project. So, next step, fetching the data. So what do we want? A list of commit messages for the user. How do we get it? Well, we're going to use three things. We're going to use Ruby, which is obviously our favorite language. We're going to use Faraday, which is an HTTP client gem. And we're going to use JSON, otherwise known as JavaScript Object Notation, which is a lightweight data interchange format. So let's write some code. We're going to create a new .rb file. As you can see, at the top we're requiring Faraday and we're requiring JSON. We're creating a class called userCommits. First step, we're going to need to hit the link for the API. This is what GitHub's API looks like in the browser. This is the link. We're going to create within our class userCommits the GitHub URL. Next, we're going to use Faraday to hit the link and JSON to parse the response. So you can see response equals faraday.get, and we pass it the GitHub URL, which is a string. And we're going to use JSON.parse response.body from Faraday to see what's coming back. Now this is a little bit more complicated than we necessarily need to make it, but this is very clear, and there's a lot of different ways to access APIs and to go out there, but this one sort of lets you know what's going on under the covers. So now we're going to new up our class at the bottom of our class userCommits file, and then we're going to put the response to get API data out onto the console. So if I call Ruby and the name of my file, I'm going to get this back. Whoa. That is the first page of every single user in GitHub. We're going to need to be a little bit more specific. We're going to initialize the class with a username. So you can see on the top we've got this def initialize. When we're passing a username, we're setting @username to equal that username. So an initialize method, if you don't know, every class basically has one, but you don't need to specifically write it out if you're not going to be doing anything with it. But right now we are. We want to store that @username. So in the bottom, we can see that when we new up userCommits, we're passing it a GitHub username string, which happens to be mine. And we're also going to use string concatenation to add that @username to the URL that we're hitting. So now, when we call it out, we're going to see login, R, Gayhart, ID, avatar, etc. That's me. But that's more than we need. So let's dig in. We're going to be using something called pry. So underneath Faraday JSON, we're going to require pry. We're going to throw in a binding.pry at the bottom of our get API data method. If we do that, when we call ruby demo.rb, call the file, it's actually going to pause us right in the middle of the process. We just hacked into the mainframe. Pry lets you pause the process and play with the results. It's super helpful. So this JSON.parse on line 16, if we set that to, say, data, which is actually a terrible name, but let's just go with it because that's what I used. JSON.parse response.body equals data. And we call data.class, we can find out what it is. And what it is a hash. That's what comes back. If it's a hash, then we can use the concept of keys and values to dig in. So if we call data.keys, we're going to get login, ID, avatar, followers, gists, subscriptions URL, events URL, etc. If we call data.values, then we see the opposite side. So if we had username as one of the keys and we call the value, it's going to be RR Gayhart. If we call, like a key to find out the events, we get the URL back. So where would you expect to find commits and all of that? Well, commit message goes along with a push event. So you're pushing code up to GitHub and your commit message says why you did it or what the code does. So we're going to look in the events. So if we call data and then in square brackets and then quotes events URL, which is our key, we're going to get back the result, which is another link. So let's update our URL to hit that link instead. So now if we call rubydemo.rb, this is what we used to get. Let's run this again with pry and let's look at the new link. So we run it again in pry, we get stopped in the middle of the process, we're assigning data equals json.parse, and if we do data.count, it gives us a good idea. It's a good idea when you're working with APIs. You can call .count to get a general idea of what you got back. And we got back 30 things. So that's 30 events that we got back. What do events look like? Well, one very easy thing to do when you're working with something like you're working with 30 different things, your first bet, what you're going to eventually want to do is do an enumerable which acts on each thing. But when we're trying to explore or figure things out, sometimes you just want to grab the first thing and play with that. Sometimes it keeps you from getting confused and locked into an enumerable while you're trying to do something basic. So if we look at the first event that we get back, let's check it out. We see we've got an ID, we've got a type, which is a push event, and then things like actor, repo, payload, etc. So data.first, let's look at the keys in that first thing. ID, type, actor, repo, payload, public, created app. So data.first, and let's put in the key type and see what it is. Like we saw before, it's a push event. Are there any other type of events? We should probably figure that out. So if we're exploring, we can use an enumerable to grab all the data, all 30 events, .collect, do, event, and grab the event type. So what that's going to do is it's going to collect each type of event, so all 30 event types. We just want to grab the unique ones because we want to see what's in there. So we can call all types, which is what we set that collection to, and call unique, and it'll knock out anything that isn't unique. So we can see just a clear picture that we have push events, delete events, pull request events, fork events, create events, and match events in the 30 events that came back to us. We need to isolate the right events in the code. So what we're going to do is move our data fetching to a private method. And the reason that we're going to do that is we could kind of build our whole class, like everything that happens in that get API data, but that isn't really what that method does. All we want that method to do is to go out and get our API data, and we want to end it there. So we're going to create a new method up here that calls that get API data, and we're going to have that be sort of our controller. That's what's going to do everything that we really care about and want to be publicly accessible. So we're going to assign the get API events to data. Again, not the greatest naming convention, but bear with me. Fetch commits is now basically running the show. So if we call this user commits.new fetch commits, we get the data back, and we're going to grab the push event data. So we make this method down here on line 22, which is grab push events. So if we make grab push events and we push it what we got back from the API, which is data here, we're going to go through the data. We're going to select each one, and we're only going to bring back or return the ones where the event type equals push event. So we're only going to bring back push events. So let's check this out with pry. Did it work? So if we run our code again, put the pry at the bottom, let's see push event data.count. We got 20, which means that we knocked some out. So that's a pretty good sign. So let's grab the first one and let's look at the keys and let's try to figure out where we think we're going to find commit messages. So I have a hunch. Payload sounds kind of important. So let's grab push event data.first, give it the key payload, and see what we get back. Looking through it. Oh my gosh, message. I got a little excited. That's exactly what we're looking for. So now we know we want to collect the payloads. So down here in 23, we're going to create another method, which is going to go through the data, it's going to collect it, and it's going to assign each one as a push event, and then it's going to pull the payload from each push event. So now, up on 17, we've got payload data equals collect payloads push event data. So now, let's pull the commits out of the push event data. So again, you guessed it, another enumerable, a collect commit history method, data.collectDo payload commits, so we're only collecting commits. Now this fetch commits is really growing. And this is basically, like I said, our controller. This is where everything's kind of happening. So let's check out a commit history and see what that looks like. So commit history is an array of arrays of hashes of everything. Now remember, what we really want are just the messages. And this gets a little tricky. A hash inside of an array, inside of another array, like it's kind of weird. So I'm going to do a little hand wavy thing. It's going to be another method and a little bit of Ruby magic. So this time, in order to collect the commit history, we're going to do data.collectDo payload. We're going to call the payload, grab all the commits, and then we're going to call on that, collect the commit out of the commit, and then flatten it. Like I said, a little bit of Ruby magic. But here we go. When we call the first one, we get a clean commit. So finally, the last thing is we want the messages. So now we're going to make a method at the very end of our fetch commits, collect messages, commit history. We're passing the commit history to collect messages. We're going through, we're calling map, which is actually about exactly the same thing as collect. We're going through each commit and we're pulling only the message. So now when I call ruby demo.rb, it's going to print out just a list of my messages. Pretty cool. So the next step, we're going to need to make the program. So let's not cram all of the code into one file. So remember we have this user commits class. What is the purpose of it? It's to get the commit messages. So what's the purpose of our program? That one's actually a madlib generator. So we're going to make a new file, madlibgenerator.rb. Class madlib generator. Notice that we don't need to require JSON or Faraday in this madlib generator because that's what we're doing in our user commits. User commits gets to handle all of that JSON and Faraday logic. Madlib generator doesn't really care where the commit messages came from, it just wants them from user commits. But we do need to require user commits. So we're going to require relative the user commits file. We're going to have a class, madlib generator. We're going to have an initialize method, which again starts with the username. And then we're going to define a method called print messages, which is going to put the result of newing up user commits.new and passing it our username. And then on the bottom, username equals R Gayhart, madlib generator.new username.print messages. Since this happens here, we can remove it from the user commits, which I'm not going to show, but we're going to get rid of the bottom part that did the printing to the console and user commits. So if we call Ruby madlib generator, why does it look like this? Well, what we actually need to do is to call the method in user commits that gets our messages. So puts usercommits.new username.fetch commits. And this is actually kind of a good thing. You don't want something or a class when you new it up to automatically just start doing things usually. You want to intentionally tell it. You want to be able to new it up and tell it when you want those commits. We want to keep our code clean, again, so just like in user commits, we want to move this idea into its own method down in private. So we're going to call in line 17, plain messages is usercommits.new username.fetch commits. And then up at 9, in our print messages, we're just going to puts it, plain messages. We also want to keep our username accessible, but we want to keep that private too. And the thought behind the private and the public is that if you have something above that private line, it's basically a public method, and any other class that's calling your madlib generator can call those methods. And some of those methods are kind of buried in there, and they spend on other things, and you want to keep them kind of private and keep things clean, so that when you do go back to your code and clean things up or mess around with things, you know what things or what methods are getting called in other places, and you know which ones are just part of the machinery. So we're going to move our add-a-reader username down underneath private. So now if we call Ruby madlibgenerator.rb, we're back to where we were. Yay! So what do you need to make Madlibs? Well, you need words. So let's define some common nouns from commit messages. If you're familiar with commit messages, you'll recognize some of these nouns you see in almost all of them. Assignment, HTML, CSS, code, commit, merge, username, test, file, form, etc. Now let's define another array of common verbs. Fixes, fixed, completed, adds, removing, delete, merge. Now, in the background, I did the same with some replacement nouns and replacement verbs, but I'm not going to show them to you because I don't want to ruin the suspense. So right now, our plain messages are sentences. But what if we want to split apart the words? So if you look down here, convert commits, data equals plain messages dot collect, another enumerable do message. So each message, we're going to downcase it and we're going to split it. And we're going to throw in a binding.pry down there and see what that looks like. So downcase converts all of our messages to lowercase. This is really important when you're comparing words. You want them to all be in the same case, otherwise they don't match. And split splits a string into an array. The default character that it splits on is space, so we don't have to pass anything in there because that's actually exactly what we want. So now, if in that binding.pry, if we call data and see the result, we can see that each commit message is now an array of each word split by itself. So adds, saving, to, file, examples, etc. Now let's create a method to replace the nouns and verbs. Data equals plain messages.collect word array downcase.split, and then we're going to call this method replace nouns and verbs on each word array. So let's throw a binding.pry and replace nouns and verbs. We know what we want it to do, but how exactly are we going to do it? Well, let's think about it. Word array, we're passing it a word array, we're collecting it, another enumerable. Let's see if the word matches a replaceable noun, and if so, we want to replace it. So word array.collectDo, if the convertible nouns include the word equals replacement nouns.sample. .sample is something that you call on an array to grab like a random thing out of it. Then, if convertible nouns includes the word equals replacement nouns.sample. Else, if convertible verbs includes the word equals replacement verbs.sample. And then we return the word. So basically, when we're cycling through a commit message, we're going to grab the first word and we're going to pass it into this method. If it matches a convertible noun, we'll replace it with a replacement noun. If it matches a convertible verb, we'll replace it with a replacement verb. And if it matches nothing, we're just going to return it. So what are we getting back? When we go through this process, we're actually getting arrays back. And that's not what we want. We want sentences. So remember how we split? We're going to join the arrays back together. And a join typically joins on, just joins together. So we're going to pass join a space in the form of a string. So did it work? Well, not so fast. I don't want to ruin the surprise yet. Let's first clean up how the data is displayed, and then we can see. Showing the data. So remember this, username equals r, gayheart, madlibgenerator.new, username.print messages, puts convert commits. It's not too fancy. So let's throw something in there. It's not super snazzy, but it'll look a little bit better. So messages equals convert commits. Then we're going to put in a string, which is a /n, which is a new line. Then we're going to put in with concatenation username.capitalize. So remember how we used downcase before? There's upcase and then there's also capitalize. Blanks commit messages so that we know whose commit messages we're messing with. Then we're going to put a dash times 50, so you can multiply on strings. We're going to have like a little line, and we're going to put the messages. So now the results. My commit messages. Tickles kitten, emasculates readme, clean up, tickles saving to bud examples, spoons with readme, epically battles, notes from week 1, etc. It worked! But will it work on anyone? Well, let's try it with the man in charge of the beginner's track here in Boulder, Mr. Jeffrey Matthews. Bug fix, convert fail message to string, emasculate version, spoons with gemspec, reduce rspec bacon dependency, reduce rspec butt dependency, tickles.gemspec, correct typo in initial release, and first hard-boiled eggs of inheritance post. And how about our event coordinator here for the Denver Ruby or the Boulder Ruby meetup, Stephen Hockman? Here's his commit messages. Adds information about the graphics dependency and but. Adds header on Beyonce and Jay-Z to separate sections of dependencies. And my personal favorite of all time, going back to one build, would love to have Beyonce and Jay-Z split as Enrico has suggested, but can't get it to work right now. Sweet, sweet success. So, as with any programming endeavor that you do with someone else, it's always good to have a retrospective. So let's have a little one. How could we have done this better? Well, number one, test first. You can use Minitest, you can use RSpec. It doesn't matter, just test. Think about a month from now. If I come back to this project, how the heck can I change anything? I won't know what will break everything. And I won't understand why I wrote the code the way that I did. I'll spend more time trying to figure it out than I spent writing the code. And if you don't believe me, that's actually exactly what happened when I tried to get this code ready for the presentation. And if you want someone to help you with your code, such as a mentor who's going to sit down and help you go through it and figure things out, you better have tests, because they're not going to have any idea what's going on without a little bit of testing roadmap. The other thing is the dangers of hard coding. So remember this guy, this array of convertible verbs? So the first couple of times you play the GitHub Mad Libs, it'll be funny. But replaces but will lose its charm eventually. You'll want to change the word around. And it's not great to have those words be hard-coded in your class. Think about using things like a simple database or a config file, heck, even reading and writing to a CSV, anything that you can do to make things that you know are going to change not be a part of your code. There's a reason it's called hard coding. Your code should be hard. It should, it's going to be flexible, but you don't want to change it on every implementation. And finally, you can actually make this a whole lot prettier. Even if you aren't ready to make an entire website for your commits, which a lot of people immediately think, oh, Rails new. The terminal actually has a lot of styling tools for a simple tool like this. There are also general coding standards around what a command line interface tool should present to the user. You can check out this document if you're interested and super bored. But basically the idea is if you think about things like using RVM for control or like even using the Git interface in the terminal, you kind of expect things to be a certain way. You expect quit to get you out of things or Q or control C. Like you expect to get information in a certain way and to have like help. It's useful to have your command line interface tools sort of follow these preset notions. But still, it's not too bad of a result for just a little bit of Ruby. There's a world of data out there that we can still access with just simple code. I think we should go out there and make the world a better and more fun place. Thanks. As I said, my name is Ramiki Gayhart. Follow me on CC and UC, and you can find the code and any other code that I've written at github.com/rrgayhart. Thank you.